part 10. In the previous part, we looked at managing state and lifecycle. In this part, we're going to look at persisting data. So the first thing we need to do is add codable conformance. So let's get started. Now we can open theme.swift and declare conformance to the codable protocol. So here, in addition to identifiable, we add codable to theme.swift, and we have automatic conformance because theme is storing raw string values which are codable. Now we can open history.swift and declare conformance to the codable protocol. So let's open history.swift and declare it to be conforming to codable protocol. Now we'll notice that there's an error. So let's fix the compile error. Here it's saying that history does not conform to decodable. So if we open daily scrum.swift, we can add codable conformance to the attendee inner struct. So in daily scrum.swift, there's an inner struct called attendee under the extension. So let's look at this attendee extension, and we can add codable conformance to it. Now we can make daily scrum codable and add conformance to the codable protocol. So in our daily scrum struct, we can add conformance to codable. Now we need to create a data store. So let's create a new Swift file called scrumstore.swift. scrumstore.swift, and for this class we can import SwiftUI and create a scrumstore class that conforms to codable protocol, to the observable object protocol. So let's go ahead and add SwiftUI and conform to observable object. Now this is a observable, so we can add published properties for the observable. So let's go ahead and add scrums as a published property. So we're going to say @published scrums of type daily scrum array equals daily. Actually, we can initialize it to an empty array. Now an observable object includes an object will change publisher that emits one of the published properties that emits when one of the published properties will change. So any view observing an instance of Scrum store renders again when the Scrum's value changes. So let's add a private static, and it's going to be a throwing function called file URL that returns the URL. Now we're going to get a error, so let's fix it. So we're going to call URL for inappropriate for create in the default file manager. So this is our file manager default object, and we can call that inside a try, and if we return the URL, that should fix the compiler error. So we're going to say appending path component to return the URL. So let's see if it builds correctly. So that is building. Now we can keep going. Now we need to add a method to load the data. So we're going to add a method to populate Scrums array from the scrums.data file. So that was the scrums.data file we had here. So let's add a method to load the data. And to load the data, we're going to add a static function called load. So that's going to load the data. Now result is the type that represents the outcome of an operation, and the load function accepts a completion closure. So we have the completion block here, or the completion closure, and the completion closure would be called async, and it can return either a array of daily Scrum or return an error. So let's keep going. So we're going to use dispatch queue to choose which task runs on the main thread or background threads. So a dispatch queue is a FIFO queue, and our application can submit tasks to the dispatch queue. So background tasks have the lowest priority, and we're going to create a dispatch queue to load the data on the background. Now we can add a do catch to handle errors. So let's create a do catch block. And in the do catch, let's create a local constant for the file URL. And it's going to call file URL. Notice that this is a capital R, capital L for both the function and the variable. Now we're going to create a file handle for reading the Scrum's data. So let's go ahead and create the file handle. Now scrums.data doesn't exist initially, so we call the completion handler with an empty array, which is here. Now we decode the file's data into a local constant called daily scrum. So in here is where we decode the data into a local constant called daily scrum, and that's going to be right before the catch block. So now that we have daily scrums, we are going to, on the main queue, pass the decoded scrums to the completion handler. So this was the completion handler, and we are going to pass it to the completion handler in the main queue. So now in the catch block, we can pass the error to the completion handler. Now we're going to add a method to save data. So let's save the data at the bottom here. So we're going to create a function called save. Again, it's a static function, and it's got a completion block as well, and we can handle the errors in the completion handler. Now let's take a look at the do catch statement. So we have our do catch statement, and we run it within the save function, but we have the dispatch queue set to run on the background. Now in the do clause, we can encode the scrums data. So we can say encoder.encode scrums. Now we create a constant for the file URL. And we can write the encoded data to file. So now we can pass the number of scrums to the completion handler. So within the dispatch queue main queue is where we pass the scrums count to the completion handler, and in the catch clause we pass the error to the completion. So in the catch clause we pass the error. Now we can load the data on app launch. So let's go back to the app file, and we can change the add state property called scrums with the state object property called store, and we're going to set the value of store to scrum store. So in our app we can remove the scrums state property and change it to add state object. Now, add state object property wrapper creates a single instance of an observable object. So we basically have a singleton here. Now we can pass the scrums view binding to store scrums. So we're going to pass a binding to $store.scrums to the scrums view. So let's do that. In our scrums view, we pass the binding to $store.scrums. Now we can load the scrums when the navigation view appears on the screen. So let's say we have our onAppear modifier. We can then add scrum store.load in the modifier action. Now we can use the switch statement to update the stored scrums array with the decoded data. So within the load function call, we can add our handler and return an error if there's an error. Now let's look at saving data. So in active state, so in our scrums view.swift, we can pass an environment property for the scene phase value. So in scrums view.swift is where we're going to pass the environment object called scene phase. Now this value has to be observed and it'll save user data when it becomes inactive. So let's take a look at the save action. So we have a save action in scrums view, and in the save action we can add the action to save. So down here in the preview we need to add save action in the preview closure. So in addition to the constant that gets passed, we can add save action and it's going to take an empty closure. Now we need to fix any compiler errors. So let's take a look at the scrums view onChange modifier. So in our scrums view onChange modifier, which is going to be on the body, so the onChange modifier is added here, and in the modifier is where we can trigger actions. So we're going to call the save action if we're about to go inactive. So we can add the save action call here in the onChange inactive phase. So in the inactive phase, we don't receive any more events, and we can take a look at the scene phase lifecycle to understand that. Now we're going to update the app to pass save action closure to the list view. So in our app, we can pass, or we can call save within the save action, which is down here. And we can bind the error to a local constant. So if there's an error, we bind it to an error. So we'll add some more error handling. So let's run the app. So now we have a new scrum here. Now we can return to the home screen, and we can even quit the app. So if we run xcrun this command, we should be able to view the path to our app data. Let's take a look at the identifier. So we have codelabspro.codelabspro, and here we can run this command. And we're going to call it codelabspro.codelabspro and data. So that gives us the path to our data. So that was the persistence part. And in the next part, we're going to look at the new API features. Thanks for watching. See you in the next one.